Hey, good morning, Algebra 1. It's college day at Banneker, so I got my Gator shirt on. Alright, let's go ahead and get started with this video. Unit 1, Packet 2, Classifying Numbers. So we're moving into Unit 1 now. We're actually getting in away from the prerequisites and into the new material. Alright, so, name, Mrs. Lucas. Alright, rational numbers. And remember, these notes are in your class notebook, so you can print them, download them, whatever you want. All right, rational numbers. So our learning objective, I can define and identify rational numbers, integers, whole numbers, and counting numbers. Okay, so you may have heard of these numbers before, but you might not know the specific distinctions between them. We will find that out today. All right, so the definition, mathematical definition of a rational number is a number that can be made by dividing two integers. A number that can be made by dividing two integers. So a number that can be made into a fraction. So this rational, the term rational, comes from the term ratio. And we talked about ratios on the second day of class, right? So a number that can be made by dividing two integers, or a fraction. All right, so some examples are 1 over 2. Let's also say that 0.75 is going to be a rational number, and that's because I can turn it into a fraction, right? I can turn it into a fraction because that's the same thing as 3 over 4. All right, 1 is a rational number. Now I know what you're saying, how can 1 be a rational number when it's not, like it's not a fraction? Well, you can write 1 as a fraction. You can write any whole number as a fraction. 1 is the same thing as 1 over 1. So if you have a whole number like 2, you can write that as a fraction using 2 over 1, right? Okay, so those are rational numbers. We'll get to more examples in a second. I just don't want to fill up your whole page. Next up is integers. All right, so integers, a number with no decimals. A number with no decimals. All right, this includes negative numbers and 0. So it's basically any number that doesn't have a fractional part or a decimal, right? So -8, 7, 1, -2, 0. These are all integers, right? So think of a traditional number line. It would be all those numbers on the number line. All right, whole numbers. Whole numbers is similar to integers, right? Similar to integers, so a number, and let me go ahead and say a positive number. A positive number with no decimals. And I'm going to say include 0. All right, so our examples are going to be 0, 1, 2, 3, 4, and so on. Right? It does not include negative numbers. It's positive. So integers include negative numbers. Whole numbers do not. So let me go ahead and write that really big here. Integer includes negative numbers. I'm going to use the hashtag sign for numbers because that's what it used to be for. And then it also includes 0. Now whole numbers, no negatives, but it does include 0. All right. And then our last definition, natural or counting numbers. So these are whole numbers starting at 1. So 1, 2, 3, 4. That's why you would use the term counting numbers. So this one is no negatives and no 0. So do we kind of see the difference between the four, right? A rational number is a number that can be made into a fraction or a ratio. Integers are no fractions, right? No fractions, but it does include negative numbers and 0. Whole numbers, or no negatives, but it does include 0. I want you to think of whole, see that O? Think of that as a 0. So it does include 0 in whole numbers. And then natural or counting numbers is the most restrictive definition. It includes the least number of examples, right? It's just counting numbers starting at 1. All right, what numbers can you place on the graphic? I went ahead and put some examples down here at the bottom, so pause the video and write these examples down. And then we're going to put them in this graphic organizer together. All right, so you'll notice something about this graphic organizer. It's some circles within some circles, right? So what does that mean? What is this graphic organizer telling us? So it's saying that natural numbers or natural counting numbers fall into every other definition. So if you have a number that's a natural number, that number is also a whole number because it's in the whole number circle. That number is also an integer because it's in the integer circle, and that number is also a rational number. So what we're going to do is we're going to start off, we're going to place these things by starting in the inner circle, seeing if it meets that definition, and slowly moving out, okay? So let's start off with negative 8 over 2. Is that a natural or counting number? Definitely not. And it's not because it's a negative number, and it's not a counting number, right? So let's move to the next one. Is this a whole number? Nope, it's not, because it's negative. Whole numbers are only positive, right? Is this an integer? Well, it's a fraction, so that won't work, right? Integers are only a number with no decimals, right? So it's got to be a rational number, all right, because it can be written as a fraction. So this negative 8 over 2 is only a rational number. It doesn't meet any of these other definitions because it's not included in their circle. It's only in the rational number circle. All right, let's try negative 3. It's not a natural number because natural numbers can't be negative. Whole numbers can't be negative. So let's move to integers. Is negative 3 an integer? It is, right? Because remember, an integer is just a number with no decimal. It includes negative numbers. So I'm going to say that negative 3 is an integer and a rational number. See how it's in both of those circles? It's not in the whole number circle, and it's not in the natural or counting number circle. So negative 3 is an integer and a rational number. Negative 8 over 2 is only a rational number. All right, we done this one, we done that one. All right, what about 0? Is 0 a natural or a counting number? Let's check our definition. Natural, whole number starting at 1. Well, that doesn't work. So 0 is not a natural number. All right, is 0 a whole number? Let's see. Whole numbers are positive numbers with no decimals, and it includes 0, right? Remember our little trick to remembering that O looks like a 0, so I know that 0 is included in whole number definition. All right, now I want you to use the graphic organizer to tell me what categories 0 belongs to. All right, I hope you said that 0 is a whole number, an integer, and a rational number, because it's in all three of those circles. All right, let's try the number 1. Is the number 1 a natural number? Let's see. Natural numbers are whole numbers, counting numbers starting at 1. Yeah. So I can put 1 in this inner circle. So how many categories does 1 fall into? Can you name all the categories that 1 is, the number 1? All right, I hope you said that 1 is a natural number, it's a whole number, it's an integer, and it's a rational number. It meets all of these categories because it's in every single circle. All right, let's try negative 2. Is negative 2 a natural number? Nope. Because natural numbers are positive numbers starting at 1, right? Is negative 2 a whole number? Nope, it's not, because whole numbers are positive numbers that include 0. Is negative 2 an integer? Let's see, integers are just numbers with no decimals, and it includes negative numbers. Well, I don't see any decimal or fraction, so yeah, negative 2 is an integer. All right, so that means that negative 2 falls into every category that it's in, right? So it's in the integer circle, and it's in the rational number circle. So -2 is an integer and a rational number, but it's not a whole number or a natural number. So we've seen the way that graphic organizer works. Whatever circles that it's included in meets that definition. And -2 is an integer and a rational number. All right, let's try 2 over 3. 2 over 3, it doesn't meet the definition for a natural number, right? It's not a counting number starting with 1. It's a fraction. It doesn't meet the definition of a whole number because whole numbers are positive numbers, no fractions, no decimals, that start at 0. This is a fraction. Is it an integer? Well, integers are numbers with no decimals and no fractions. So see, if I divided 2 over 3, if I divided 2 over 3, put that fraction in the calculator, it would give me a decimal. So it's not an integer, but it is a rational number because rational numbers are numbers that can be made by dividing two integers, or a number that can be written as a fraction, right? So, what definitions does 2 over 3 meet? I'll give you a second to figure that out. All right, I hope you said one definition only. It just meets the definition of a rational number. It's not in any other circle. It's only in the outer circle. All right, let's try 4. Is 4 a natural number? Yep, it looks like it is. It's whole numbers, counting numbers that start at 1. So 4 falls into that category. So I'm going to put 4 right there. All right, so I want you to take a second and tell me what categories the number 4 falls into. All right, I hope you said that 4 falls into the natural number category, the whole number category, the integer category, and the rational number category. 4 meets all of these definitions. 4 is a rational number, 4 is an integer, 4 is a whole number, and 4 is a natural number. All right, go ahead and flip this over. All right, so if we had rational numbers, you know we got to have irrational numbers, right? All right, so after this graphic organizer, we should be able to define irrational numbers, and we should be able to identify if a number is rational or irrational. This first page was all about rational numbers. This second page, we're going to define irrational numbers. All right, so an irrational number is going to be a decimal that does not end, so that means it goes on forever, and it does not repeat. All right, so it has to go on forever, and it can't be a repeating pattern. It has to meet both of those definitions, right? Okay, so the most obvious definition of an irrational number is the symbol pi. Pi goes on forever, and it doesn't have any sort of repeating pattern. Another way that you could see an irrational number would be 0.3278 ... Those dots mean it goes on forever, and you can see there's no pattern. The numbers are not repeating, right? All right, a non-example would be a decimal that looks like this. 0.32 with a line over it. So what that means is that this pattern of numbers, this order, is going to repeat forever. So it's going to look like 32, 32, 32, on and on and on. So, although this decimal doesn't end, it does repeat. So since this decimal repeats, it's actually a rational number. So to meet the definition of irrational, it has to do two things. It has to be a decimal that doesn't end and a decimal that doesn't repeat. And we'll pick this up in class.